This is what we did last time, comparing two different groups. One was survival times, cancer drug with treatment A, drug A, survival times with drug B. We did a two-sample test. We had our hypothesis, went through a whole lot, and at the end, we ended up with this. So prior to that, we had that part. I removed outliers. I still did not get a normal distribution. Clearly, I violated the assumption. So no matter what my test tells me over here, that is not reliable because I violated the assumption. Good. So major problem. So how do we get around this? I'll save it as a separate file. And make changes. Again, do run these at home. If R doesn't work, talk to me. So what I'm going to do, last time we did a two-tailed test, right? Can I do a two-tailed test here? Absolutely. I just have to switch around Y and X, go back and forth. But let's just stick to a right-tailed test where we're going to say or test that the median first sample bigger than second.
You do have a question?
Yes.
Why did we pick a two-tailed test for this again?
Just to show an example, but we could have done a right-tailed.
Okay.
The reason why I picked is because of that picture, right? There was significant overlap, so maybe a two-tailed test would be reasonable. Of course, one could have done. So in the previous code, I'm going to get rid of all of that. Let's not jump to conclusions. Just the last part, I'm going to get rid of that. And our case is an unequal variances. The test that we did, it was a two-tailed test. The average for the first group is not equal to the average for the second group. Here, we're not going to use average, rather, we will use
Median.
Median, very good. So I will use uppercase M, standard notation. Median survival time of treatment A. Now that is going to be our X and is greater than the median survival time of treatment B. Good. That goes down here, my bad. So greater than is the alternative. The null is less than or equal to the opposite of that. In the initial summary or initial description earlier today, I called it as m_x and m_y, same for mx, my. Previous case from t-test, our conclusion was that whether we made the assumption of equal variances or otherwise, our answer was to reject the null. But since we violated the assumptions, we are going to do a non-parametric test. So when we did t-test, we used the same function to do a two-sample t-test and a dependent t-test. Same over here, there is one function which is Wilcox.test. Instead of t, we have Wilcox. The first sample is x, so in our case, that would be survival. The second when we do it in R, it doesn't matter whether we have ties or not, because R has the option to deal with it. Hopefully it shows up here. So here there is an option called correction. We can make that correction internally, but it doesn't matter when we do it using R, because the ties affect the variance, and it is going to affect how we compute our test statistic and its variance. So with R, not a big deal. So I'll call it survive.wc. Comparing survival times for treatment A against survival times for treatment B. Objective, median for A bigger than median for B. Why? We want to come to a conclusion that is appropriate. Everything is done internally. We don't have to worry about all of this stuff, because I forget. Let me look at the article. Yes, it has the modified version. So that is our conclusion. I get a number 2,459.5. Yes. Now, is that U?
Yeah.
Or is that W? That's U. So even though it is full or shown as W, the value that we found is U. The p-value for our test here is 0.001087. Informal way to understand the p-value, it is the probability of type 1 error, false positive. In other words, you're not make the chances that you are making a mistake in rejecting the null is 0.001087. Is that a huge probability? No, that's 1 in 1,000, relatively small. But what was our initial standard when we started this? We were comfortable with a 5% error, right? As long as the probability of type 1 error is less than 0.05 or equal to 0.05, I can comfortably reject. I'm getting a number way smaller than that. Before we jump to conclusions again, let me put the alternative. It has to be greater. So I believe the default value is greater, but I don't want to take any chances. Here doesn't give you a confidence interval. So I'll throw that in too. Confidence level 0.95. Tolerance and all that stuff, it's computational. You needn't worry about it. Run. Let's see. So it's actually half of that. By default, it is doing a two-tailed test, so I'm going to change that value. But the conclusion doesn't change. That value is definitely less than the alpha that we set. So minimum probability at which we can reject the null. (0.00054337), and it is definitely less than the initial value of alpha that we set, which is 0.25. Good. Now, what does that mean? Okay, if you have to explain it to someone, you just paraphrase the figure. If you have to explain it to someone, let's say you are the researcher, you want to make sense of the result, how would you explain?
Okay, so the minimum probability was to reject 0.05, and our p value is 0.0005.
Okay.
It's less than 0.05, so our probability of making a space one error is really, really low.
I'm delighted to know that you can read well.
OMG!
You've pretty much read everything. I want you to make an inference. If you are the researcher, you look at these numbers, what are you going to say? to your audience.
That we're not gonna make an error. I'm gonna make an error. Really well.
Okay, what is the purpose of this study? Juliana. Okay, anyone else from your side? I'll give you a hint. Let's go back to our initial case or initial statement right over there. The hint is between lines 38 and 46. Yeah. So that is your research hypothesis. That's where things started.
Go into about how it's not only the median and variances, so it's not the same amount. Right? Am I not right, correct?
Johnson,
I want to say that if the type 1 error value is 0.005, that means that like out of 1,000 times, 995 times, it will be below that. The confidence interval is-
great. You were all talking about, scholars of statistics. But if you want to explain it to the general audience, Omar,
I was gonna say, the probability that the median for A is greater than the median for B is 0.5%.
Wait, isn't that the opposite?
the probability of that or the probability of making a mistake.
Making the mistake would mean that.
Probability of making a mistake that the median of A is greater than the median of B is very small, right? 0.0005. Great. Hill,
Still
you're not answering the bigger question. What is the utility of this test if you are working for a lab, if you are working for a pharmaceutical company?
Okay. So the median survival time of treatment A being greater than the median survival time of treatment B, the probability that you're gonna make a mistake in making that conclusion is really, really small.
Again, great job.
Damn it.
But that's not what you're trying to make it so that people can understand in normal terms rather than.
Exactly, in simple terms, if you want to explain after looking at all the evidence, what is the final conclusion as a researcher that you can provide to the general audience? Riley,
This evidence for treatment, one treatment A is more effective.
hit the nail on that coffin. Survival did not survive. Too bad. Nail on the coffin did not survive. Okay. Yeah, no. So drug A seems to be more effective than drug B, or treatment A is more effective than treatment B. All of your inferences are correct. Nothing wrong with whatever answers you gave me. You are improving. The point here is, how do you convey it to the general public? If you talk about p-values and significance and power, no one's going to understand. So, given the choices between a two-sample test, t-test, and Wilcoxon, even though the conclusions were the same, which is appropriate? That one. Why? Distribution. Yes.
Can you put the simple terms in our?
Yeah, sure. Our final conclusion. Good. Now, one of the things that you should know in the final test conclusion, it does not say mean, right? Rather, it simply says a location shift. Because the moment you say mean, then there is an underlying distribution. Since it is distribution free, all we are saying is, all right, this is my center location. Did the data move away on that location? Is there a shift? There is a shift, and that is significantly greater than 0, the middle value. Good. Confidence intervals are not that intuitive when it comes to Wilcoxon. So should you report it in practice? No, I wouldn't do it. Difference in location, I wouldn't do it. Because those terms would actually make things more complicated. I can simply report p-value if it is less than 0.05, and we have evidence to conclude that treatment A is likely to offer greater survival times than treatment B. End of story. Good. So key thing to note, even though t-test and Wilcoxon came to the same conclusion, this is appropriate because there are no assumptions regarding the underlying distribution. Good. Okay.